Okay, in this tutorial we're going to be looking at sketching graphs of reciprocal functions. Okay, so consider 1 over f of x. Okay, well the function will be undefined when f of x equals to 0 because we'd end up with 1 over 0 which is undefined. So if f of x is equal to 0 then 1 on f of x is undefined. Okay, and as f of x approaches infinity, then 1 over f of x is going to approach 0. So as f of x approaches infinity, I think as f of x gets really big, well, what happens to 1 divided by f of x? Well, 1 divided by a really big number is a really small number or is approaching 0. Okay, so if we're going to sketch some functions, okay, there's a few things that we need to remember. Okay, so we'll go through some worked examples. Okay, so the first worked example we're going to look at is sketching the graph of y equals 1 over x plus 2. Okay, so what we want to do to start off with to get our head around it, okay, is to draw a bit of a sketch of y equals just x plus 2. So this is just y equals x plus 2. Okay, so we know our x-intercept will be -2 and our y-intercept will be +2. Okay, and that's all the information that we really need to know. Okay, so one of our big ideas, okay, is the x-intercept of the denominator becomes a vertical asymptote. Okay, so our x-intercepts become vertical asymptotes for our new graph. Okay, that's one big idea. The second one is y-intercept y1 becomes 1 over y1 for our reciprocal graphs. Okay, so what we'll do is we'll sketch this one on the same axes. Okay, so we know that we've ended up with a vertical asymptote at -2. Okay, and we know that we also cross 1 on 2, which is just a half. Okay, is our y-intercept. Okay, and so from there, okay, what we can do is we can sketch our graph that is going to come down like this, across, and like that. Okay, so the reason for that is we've got this horizontal asymptote, okay, because as we start to get bigger and bigger values here for our x, okay, then overall this is going to get a lot bigger, and as we said earlier, as our f of x increases, okay, as we approach infinity, we approach 0, okay, and so we end up with a horizontal asymptote. Okay, so you can see that in here. Okay, and similarly, if we have a really large but negative value for f of x, then we still approach 0. Okay, it's just we approach it from the negative side. Okay, so that's the first worked example we're going to have a look at. Okay, our second one, just turn the page. Okay, is we have the function y equals 1 over x plus 2 times x take 4. Okay. So from our work with quadratics, okay, we should know, okay, that means that we have a x-intercept at -2 and we have another x-intercept at 4. Okay, so we're only considering just the denominator at the moment and what that graph would look like. Okay, so when we do that, okay, then we get a nice graph that looks like something like this. Okay, we know our turning point is going to be halfway between here. Okay, so we know our turning point is going to be at 1. Okay, and if we put 1 into our equation here, okay, you'll find that we get -9. -9 and 1 for our turning point there. Okay, now that doesn't matter too much at this stage. Okay, the turning point, what we really need to worry about is our x-intercepts. Okay, oh, and sorry, of course, our y-intercept is when x equals 0, so 2 times -4 is -8. Okay, so we need to think, well, our x-intercepts are at -2 and 4, so these are going to become vertical asymptotes. So you can put those on. And another one here. Okay, and the other thing we need to remember is that our y-intercept, okay, is the reciprocal, so it's 1 over -8, so it's -1 on 8. So it's going to be just a little bit below our our x-axis there, so it's -1 on 8. Okay. And then we need to think what's going to happen. Okay, if we're below our x-intercept here, okay, we're going to end up coming like this. So go lower. Come like that, and again we have a horizontal asymptote that is our x-intercept. Okay, and then in the middle we're actually going to come up like this through our y-intercept and then back down. I should draw my axis a little bit longer here because we're also going to come down this way. Okay, and if you're ever unsure of the shape of the graph, it's reasonably easy to just actually pick a point either side of your x-intercept or your asymptote and sub it into our equation to find out. So if we were to say pick a value such as, well, we might be a little bit less than 2, so the -2, so let's put in say -2.5. So if we say we have 1 over -2.5 plus 2 times -2.5 take 4. Okay, well we have 1 over -2.5 plus 2 is -0.5 times by, well, -2.5 take -4 is going to be -6.5. Okay, so going to come up over here, so that means that we're going to be 1 over, well, we're going to end up at 3.25, 1 over 3.25, and you can see, well, that's going to be positive. So we know we're above our x-axis. Okay, we should understand the nature of our graphs as we approach asymptotes, okay, and know that we increase, so as long as you know which side the x-axis you're on, you should have a pretty good understanding of how it's going to go. Admittedly, in between it, you might be a little bit unfamiliar with that, okay, but again, it's only a matter of selecting a point that you could sub in here. You could sub in, say, -1.5, and you see that you'd end up with a negative answer, so you must be below. Okay. So there's a couple more worked examples that you can have a look at in the textbook. I'd recommend looking at worked example 8 and 9. Okay, similar ideas, it's just taking it slightly further with some other worked examples. Okay, so that should be enough to get you cracking on those.